Systems of linear equations in three variables. You're used to seeing linear equations that look like this: ax plus by equals c. And when we solved systems of linear equations in two variables, we would have two equations that look like this, and we'd put them together and use either substitution or addition to solve the system of equations. Well, a system of linear equations in three variables look like this. We have the variables x, y, and z instead of just x and y. And when we were solving systems of linear equations in two variables, our solution would be an ordered pair that look like this, our x and our y. When we're solving systems of linear equations in three variables, our solution is going to look like this. It's called an ordered triple, and it's x, y, and z for our solution. Well, before we solve some systems of linear equations in three variables, let's look at how we can tell if an ordered triple is a solution to the system. Here we have an ordered triple, -1, -4, 5, and it says to show that the ordered triple is a solution of the system. Well, what we have to do in order to show that it's a solution to the system is just plug those numbers in for the variables and see if it makes a true statement. And we have to do that to all three equations. So if I plug -1 in for x, -4 in for y, and -5 in for z into all three of these equations, let's see what happens. All right, if I plug in -1 for x, -2 times -4 for y, plus 3 times 5 for z equals 22. I need to follow order of operations and multiply before I add or subtract. So -2 times -4, that would be a positive 8, plus 3 times 5 is 15. And that gives me 7 plus 15, which is 22. So both sides of these equations, of this equation, balances. So we know that it works in that equation. But that's just one. We need to plug it into all three. So I'm going to do the same thing with the second equation. I'm plugging in -1 for x, -4 for y, and 5 for z. Again, if I follow order of operations, I get -2 plus 12 minus 5 equals 5. -2 plus 12 is 10. And 10 minus 5 is 5. Okay, so it works in the second equation. We have one more to check. All right, if I plug this into the third equation, -1 for x plus -4 for y minus 5 times 5 that's a 32. That's -3 minus 4 minus 25. Okay, so that's -7 minus 25, which is a -32. So since it came out to be true statements in all three equations, then we know that this is a solution to the system of equations. Now we're going to solve a system of equations. Okay, so we have these three equations. The first thing that we need to do is label our equations. I'm going to say that this is equation 1, this is equation 2, and this is equation 3. Now we need to choose two of the three equations and put them together and use the addition method to eliminate one of our variables. Well, and you could choose any two of the three equations. You could choose 1 and 2, 2 and 3, or 1 and 3. and pick any of the three variables to eliminate. So there are lots of different paths that you could take to get to the same answer. There's no one right way to do this. So I'm going to choose 1 and 2 because if I add those together, the z's are going to automatically cancel out. So let me write what I'm doing here. I'm taking equation 1 and equation 2 just like they are. So let me write those out. Okay, now we have the two equations, and if I add them together, x plus 3x is 4x, 4y plus 2y is 6y, my z's cancel, and that equals 28. Well, I have just created a new equation that only has two variables. So I'm going to name this equation A. Now I'm going to need to make an equation B that has the same two variables, and I need to do that by using the equation that I didn't use to begin with. So since I used equations 1 and 2 to create A, I have to use equation 3 to create B. Now it doesn't matter if I combine 3 with equation 1 or equation 2, but I have to use equation 3. And I also have to make the same variable cancel out. So I need to get rid of the z. Okay, so I am going to use equation 3. And I'm going to leave it just like it is. Well, in equation 3, my z has a coefficient of positive 2. So that means to get it to cancel out, I need to combine it with a negative 2. So I'm going to use equation 1 and multiply it times 2, and that way my z's are going to cancel. I could have chosen to use equation 2 and multiply everything in that equation times negative 2, and then my z's would have canceled. Either way, it would have been okay. Okay, so I wrote equation 3 just like it is, and I took equation 1 and multiplied everything in equation 1 times 2, and now I'm going to add the two equations together. When I add them together, I get 4x plus 5y, my z's cancel, equals 24. So now that is my new equation B. Now I need to take equations A and B and combine those. And I need to get one of the variables to cancel. So we started out with 3 variables. Now we have 2 variables. We want to get one of those to cancel, so we have one variable and we can see what one of the variables represents. Well, if I combine equations A and B, all I need to do is multiply one of those equations times a negative 1 and my x's will cancel. It doesn't matter which one. I'm going to multiply equation A times negative 1, and I'm going to leave equation B just like it is. Okay, so I took equation A and multiplied it times negative 1, which just changed every sign, and equation B I wrote just like it is. And now when I add them together, my x's cancel, and I get negative y equals negative 4. Divide by negative 1, and y equals 4. Okay, so I figured out what one of the 3 variables are. Now that I have one of the variables, I need to take it and plug it into either A or B. It doesn't matter which one. I'm just going to take it and plug it into B. Okay, so if I plug it right here into B, that gives me 4x plus 5 times 4 equals 24. All right, so that's 4x plus 20 equals 24. Subtract 20. So 4x equals 4, divide by 4, and x equals 1. All right, so now I have x and y. Now that I have x and y, I need to take both of those and plug it into either equations 1, 2, or 3. It doesn't matter which one. I'm going to choose equation 2. So if I plug in 1 for x, so in equation 2, if I plug in 1 for x, that would be 3 times 1, plus I'm plugging in 4 for y, so 2 times 4, plus z equals 8. That gives me 3 plus 8 plus z equals 8, which is 11 plus z equals 8. Subtract 11, and I get z equals -3. And my ordered triple, or the solution to my system, is 1, 4, -3. And that's how we write our solution. Okay, let's try another one. So like I said, the first step is to label our equations. So this is my equation 1, equation 2, and equation 3. But if you'll notice, my equation 1 only has 2 variables. So that's what our equation A and B have, is we're trying to get down to 2 variables. So since my equation 1 only has 2 variables, that can also be my equation A. So I'm going to take equations 2 and 3 to get a B, an equation B. But I have to make sure to cancel out the variable that my equation A does not have. Well, if you'll notice, my equation A, or my equation 1, doesn't have an x. So when I combine 2 and 3, I need to get the x's to cancel. In order to get the x's to cancel, I'm going to multiply equation 2 times -2. So -2 times equation 2, but equation 3 is going to stay just like it is. Okay, so I multiplied everything in equation 2 times -2, and I rewrote equation 3 just like it is. So now when I add these together, my x's cancel, and I have -7y. Oh, and my z's cancel also. Equals -35. Okay, so now I need to divide by -7. And that gives me y equals +5. So now that I have my y, I'm going to take it and plug it into equation 1, since that only has 2 variables. And if I plug it in there, then that'll give me what my z is. Okay, so let's plug it into equation 1, or equation A. And that's 2 times 5 minus z equals 7. Okay, so that's 10. I'm going to subtract 10, and I get -z equals -3. Divide by -1, so z equals 3. Okay, so now I have 2 variables. I have y and I have z. Okay, so I need to find x. So that means I need to take those 2 equations and I need to plug it into one of the original equations. Well, I don't want to plug it into equation 1 because there's not an x. I need to plug it into either 2 or 3, and I'm going to choose to plug it into equation 2. So if I plug it into equation 2, I have x plus 2 times y, which is 5, plus z, which is 3, equals 17. Okay, so that would be 10 plus 3 So x plus 13 equals 17. Subtract 13. And x equals 4. So my solution, my ordered triple, is 4, 5, 3. Okay, we're going to do one more. Here are 3 equations, and again, I'm going to label my equations, equations 1, 2, and 3. And like I said, it doesn't matter how you start, it doesn't matter which 2 equations you choose, and it doesn't matter what variable you choose to eliminate. I am going to go with equations 1 and 2, and I am going to eliminate z. So if I want to eliminate z, then I'm going to leave equation 1 just like it is, and I'm going to take equation 2 and multiply it times negative 2. So I've written equation 1 just like it is, and I took equation 2 and multiplied everything times negative 2, and I'm going to add those together, so I get negative 4x plus 7y. My z's cancel, and that equals negative 11. All right, so I've just created my equation A. Now I need to create an equation B. Since I used equations 1 and 2 to get equation A, I have to use equation 3. And since I got z to cancel out, I have to get z to cancel out for my equation B. So if I'm going to use equation 3, it would be easiest for me to combine it with equation 2 and multiply equation 2 times 3 to make my z's cancel. So I'm going to have equation 3 just like it is. And equation 2, I'm going to multiply everything in equation 2 times 3. So equation 3 is just like it is, and equation 2, I multiplied everything by 3. And now I'm going to combine those 2 equations, and that gives me 10x minus 11y. My z's cancel, equals 21. So this is my new equation B. So now I need to combine A and B, and I need to get either x or y to cancel. Well, I think it would be easiest to get the x's to cancel. And to do that, I'm going to multiply everything in equation A times 10 and everything in equation B times 4. Okay, so I've multiplied everything in equation A times 10, everything in equation B times 4. When I add them together, my x's cancel. I get a positive 26y equals negative 26. And when I divide by 26, I get y equals negative 1. Okay, so that's my first variable. Now to get another variable, I need to take y and plug it into either equation A or equation B. I'm going to plug it into equation A. So if I take negative 1 and plug it into equation A where the y is, I get negative 4x plus 7 times negative 1 equals negative 11. Okay, so that's negative 4x minus 7 equals negative 11. I'm going to add 7. And I get negative 4x equals negative 4. Divide by negative 4. And x equals positive 1. So now I have x and y. I'm going to take both of those and plug it into either equations 1, 2, or 3 to get z. I'm just going to plug it into the first equation. So if I plug it into the first equation, 2 times 1 for x plus negative 1 for y minus 2z equals negative 1. Okay, so that's 2 minus 1 minus 2z equals negative 1. 1 minus 2z equals negative 1. Subtract 1 from both sides, and I get negative 2z equals negative 2. Divide by negative 2, and z equals 1. So my solution, or my ordered triple, is 1, negative 1, 1.